Now we are going to cover our topics of functions, OOPs, and file handling in an advanced Python. So we are going to cover full theory with examples and practice questions also with fully explained solutions and organized into cells as well, like 4 minutes. So here we have agenda of our session. So here we are going to understand functions and modules like def function, parameters and return values and star and double star keywords and lambda function and scope import. And we have now object oriented programming like class, object, inheritance, polymorphism, encapsulations and Dunder method. So and after that we will do file handling like exception handlings and reading and writing files and try to accept file finally. We will use try, except, or finally, and we will raising the creating a custom exceptions as well. And in advanced Python libraries, we have comprehensions, generators, and decorators, and regular expressions, and popular libraries. So each unit will be closed with 3 practice questions. When we talk about functions and modules, so writing usable and organized code is known as function. So packaging of a logic into reusable blocks is known as function, and a function is named because it is usable block of code which is defined using the def keyword. And we talk about parameters are placeholder listed in the definition arguments and are actual value passed. With these all things we have covered in our previous lectures, like we have done positional arguments, default keywords and keywords and variable positions we have done, and we have also completed variables and keywords. So we have done combining of default and star keywords and double star keywords. So let's understand how it works. So star nums gather every extra positional argument like 10, 20, 30 and automatically into the tuples it adds. And here we see tax equal to 0 is a default keywords, and we know that here overridden to 0.05 by color and double star extra scope up by any remaining keywords and arguments into our dictionary. Just note and rush orders like this here. So let's do this example in our compiler as well. Let's not do it. So here we have lambda function. So small anonymous and single expression functions are known as lambda function. So the lambda function is a compact, anonymous, and single expression function with no def or return keyword needed here. In lambda, with that signs is a sort and throw function passed straight into the map and filter it and sorted. So the expression after the colon is automatically returned. A lambda cannot contain full statement. So here we have square is equal to lambda, and lambda will be as x, which will be x multiplied by x, and we will add lambda a, and then we will have b will be equal to a plus b, and then we will print square of 5, and we will add 3 plus 4, and numbers will be 1, 2, 3, 4, and we will print these numbers like print list map lambda of x of square and then nums. So we will get output as 25 for the first as x into x. 5 into 5 will be 25. Then 4 plus 3 will be add, that is 7. And then we will print the list of the numbers. So by multiplying them with 2. So 1 will become 2, 2 will become 4, and 4 will become 8, and 3 will become 6. After like this, it all will uh, we have printed a list and after multiplying it by 2. So here we have scope and modules. So where name lit line and how to reuse other people's code. So a variable created inside a function is local. That means when we create a variable inside a function which is defined by def, that is a local function and it exists only in that function and it can be used while that function is running only for that only. And Python can resolve names using the legb rule, which is local including global, built-in checked in that order, like this. So it will first of all localize it and enclosing it, then globalizing it, and then it will build it, and then it will check that order. So a module in a single is saved in .py file, and import module will be underscore name that will bring its function and variable into the scope. If we talk about pip install lets you add third-party packages from PyPI on top of Python's built-in standard libraries. So if we talk about global scope and importing a module, we have combining a module. So this means combining a module by importing it with a global keyword. Like we have to let's understand how it works. So random dot randit of 1 to 6 simulates a dice roll each call, and the random module must be imported first. So we are importing the random. So after that we are counting it with zeros. Let's understand. Global counts tell Python to modify the module label counter and not create a new local variable. Since randit is random, the exact number changes every run. This is a representative sample. So here we have imported our file random for dice roll, and then we will start counting with zero. And after we have to define a function rollback and track. After that we have to global count, and count will be as plus one. Then we will return random dot randit as 1.6, and then we will print the roll and track, and we will then again print the roll and track. After each iteration it will change its output as randomly. And in the third, we will count total rows. So for that, we have to use count statement, and if we use that statement, that will we count that we will be able to count the total numbers of moves we have taken. So in this case, we have printed only two cases, so our total rows are as two only. We are going to run this code. If we run this code in our Python compiler, we have defined a function greet with our name, and then we are printing messages. We can see we have defined a function greet and we have name. In that we are returning f hello and then name. So our message is greet to Maya and the message is hello. With the printing message, we are after that we are printing greet Sam. So the message of hello being printed to Sam by hello Sam. This is how we can do. After that, we have another example in which we have done our art and waste. Here we have some kind of errors. I have to correct it before running the code. So here we have defined a code as num, tax, and extra. So subtotal will be of sum of the numbers, nums, and we will print the subtotal of as subtotal, and we will print tax as tax, which is default value of 0, and after adding tax we will get some other taxes, and we will print information like extra will be like something, and then we will print it all. We will going to get like 10, 20, 30. We have total of these numbers, and tax we have zero point 0.3, and notes will be have extra as notes as just order. So we have total. So we have numbers like 10. We have numbers as 10, 20, 30. So the sum of numbers will be as 60. 20 plus 10 will be 30, 30, 30, 60. And tax will be as 0.05. And the extra notes will be as just order. So this is how it has been printed here. Here we have lambda function. Let's operate it and let's see. Here we have the square as lambda, and we have a value x, which is 5. Here we have assigned the value of x as 5, and we have add lambda as two variables a and b, and the function will be as a plus b. And if we are printing square and we are assigning value x as 5, if the output will be as 25, and we are printing add with assigned value of a and b as 3 and 4 respectively. So the operators after the operating this, it is printing addition of 3 and 4 as 7, and numbers we have like 1, 2, 3, 4, and in the list form it is mapping the lambda. After multiplying it with 2, it printing the numbers in the list form as list of 2, 4, 6, 8, which was previously was 1, 2, 3, 4, which is multiplied by 2, and then it has been printed. When we do this function, This we are importing our random as zero. Count we are starting with zero, and after that we are defining a role and track and a global count, and the count will be as plus one, like count will be count plus one, that we are counting the total number of moves, and then we will return the random dot random from 1 to 6. We can print from only from 1 to 6 only, because the dice have the value from 1 to 6. So roll underscore and underscore track, let's say random value. If we write in value like 54, let's see what happens. So here we are having error. This is because we are assigning greater values than this. And if we write 5 as well, we are writing 5, we are getting error because we have a fixed range of 1 to 6, and we have to give, it will print randomly values. But if we write values by ourselves, it will not be random, so it will show error. After that, it will be showing random values. It has printed 2 times 5. Let's write something else. Print roll and track, then a random value by empty. So here we can see we are getting a random value like 1361, and the total roll will become 4. So after that, so we have some practice questions as well to check the concept whether it was understandable or not. We have first question as what keyword is used to define a function in Python? So the answer is def function, as followed by function and name and parenthesis containing any parameters. What does a function return if it has no explicit return statement? So it will return none, as Python implicitly returns none whenever a function body finishes without hitting a return statement. And if we talk about last question is what is the difference between star arcs and double star keywords? So a star arc is collect extra positional arguments into the tuple, but double star keywords collect the extra keywords uh, arguments into the dictionary. So star arcs is used to collect the positional argument into the tuple, and double star keywords collects only the extra keywords. Arcs collects positional, extra positional, and keywords collects extra keywords in the arguments to the dictionary. This is also the difference. And arguments to the tuples happens in star arcs. This is a common difference in them. So we have a question here. Write a function to apply what we have learned. So write a function as called is even that takes a number and return true if it is even and false otherwise, and test it with a number between 7 and 10. So here we have a number of n percentage 2 that will be equal to 0, and which will evaluate to true whenever n is exactly divisible by 2, and false otherwise, and the function directly returns the Boolean result of the comparison, no if else needed at all. So this is a one line body, and this one line body is common idiomatic way to write a simple predicate function. So let's write it here. We don't have to write in range, we have to write for two numbers only. In the question, we have defined a function of being even. If the number will not will have remainder as zero, by dividing two, it will be even, and because of that, it will print Boolean function by confirming is even of a certain number, and the number in our first example is 7. So 7 is the number is 7 is a odd number, and it will leave remainder as 1 by dividing by 2. So it will return false as it is not an even. And if we talk about our second example is 10. So 10 is also an even number. So 10 is an even number. So because of 10 leaving remainder as 0 by dividing by 2, so this is because of that it is returning as true. Let's write some another examples in that, like print is even, and then we have 13. 13 is not correct. So let's write 7, 13. Like this, if we are taking any kind of number, if we are running it, we are just getting simply in the form of true and false according to the number being false, even and odd. So here we have a recap of what we have learned in this unit. So we have learned about functions that are defined with def, which takes parameter and return a value or none by default value we have settled. We have learned about double star keywords and star keywords, which let a function that which accept a flexible number of positional and keyword arguments. And then we have a lambda function, which are compact, anonymous, and single expression functions, which are ideal for short callbacks. And we learned about modules and packages, lets you to reuse both your own and from the standard library of PyPI. Modulus packages that lets you. And then we have our object-oriented programming, which is modeling real-world entities with class. So we will go to understand it as well. Let's start our topic. Mhm. The first is classes and objects. The blueprint and instance model has been given. So a class is a blueprint for creating objects, and then an object is an instance there is a concrete realization of that blueprint. So underscore init is initialization, uh, underscore init, and then underscore is a constructor which runs automatically when a new object is being created and setting up its attributes. And if we talk about self refers, itself refers to the specific instance being operated on, and it must be the first parameter of every instance method. And attribute store an object's data, and methods define its behavior and the action it can perform. So now we are going to do our first code. Here we have defining a class and creating object. The init constructor in action is being used. So we have created a class of dog. We have defined and we have initialized as self name and breed. We have a self dot name as name and self dot breed as breed. And we again define bark. We are defining function bark of self, and then return we will returning by using f statement by self dot name. We will say woof, and in a D1 dog will be Rex Labrador, and we will going to print D1 dot birth or print D1 dot breed. So how does it going to work is like dog Rex Labrador automatically calls init and creating a new object with those two attributes. So those two attributes are name and breed. And D1 dot bark calls the method on the specific instant like self inside the method that refers to D1. So D1 is like dog and then Rex Labrador, and every object which will be created from the class will keep its own independent copy of name and breed. So we will going to print this code to check does it working properly, is it working properly or not. So for that we will use a compiler, Python compiler, and then we have defined as we have to remove it first before doing code execution of code. So and in the third line we have a error as self dot name equal to name. It should be like this here as well. Now you can see we have printed d1 dot bar. So they says Rex says bar woof, and we are printing d1 dot breed. So the breed is Labrador. So it is printing Labrador. The name of dog is Rex, and it says woof, and the breed of the dog is Labrador. So we have done. Here we have access modifier, that is an encapsulation. So Python's naming conventions for controlling access like public, protected, and private. So if we use public, the syntax will be self.name. If we are using protected, we use self.name, self._name. And if we are using private, we are using it as self dot underscore name. So the public can be the public name can be accessible from anywhere by anybody, and protected conventional only internal use is still accessible for some only permittable persons can access this. And a bit about private name, as name suggests, not directly accessible from outside. Only uh, some persons like privately we can access these type of codes. Saying that where Python does not enforce true privacy, leading underscore are a strong convention, not a hard restriction. So we have, if we talk about what does encapsulation means, is it like we have a bottle and we are filling it with water and we are closing it, and in like that if we are doing, we are protecting water, and only the persons who are inside bottle can directly access that. So that is like private. Or we have some person like outside the bottle, we can take and drink water. So private is like bottle, you have bottle and you can drink water from it, that bottle. We talk about protected. Protected is like the freeze in your house that will be as protected. Only few people in your house can access that water. And we talk about public. If you are in the hospital or like mall, everyone can access that water from the tap like that. So we have inheritance, reusing and overriding behavior from parent classes. So how does it work? So class cat animals make cat inherit every attribute and method from animals automatically, and cat overrides speak and replacing the parent's version. This is called method overriding. And insistence is instance. C animal is a true because cat is a subclass of animal, even though C itself is a cat. So we talk about definition of inheritance is like copying the attributes of parent class to the child class. We cannot say parent class or child class. It will be automatically will be parent class uh, if a class is copying attributes and data from another class. So the first class which is copying the data will be treated as child class, and from where it is copying the data, that class will be treated as parent class. So here we have a class of animals. So in that class we have defined name of the animals and self, and then we have a class of cat which is an child class of animals because it is using the traits of the animal class. So we have defined street self. So if they return the self dot name say meow, and C will be as cat whiskers. If we will print the C dot speak, it will whisker and will say meow. And if we print each instance C is an animal, so it will be animal. So it will return true. So if we will copy it and if we will print it, For line 7, we have our class animal. Unindented does not match any other indentation label. Here we can see that we are getting our correct output as discussed same now. As we are printing C dot speak and C is having discussed and before we have arranged that same now in the same dot name of C cat. We have done inheritance and then we will going to do polymorphism. So one method main and many implementations. So how does it work? Let's understand. So both classes define some methods with the identical name, like area, but with completely different bodies. And the loop calls shape dot area without caring which exact class shape is, and that's a polymorphism work. So the loop calls shape dot area without caring which exact class shape is. So this is all because of polymorphism. So this lets you write a generic code that works uniformly across many related interchangeable classes. So by the example, we can see that we have a class of circle, and then we have defined it, and we are giving a value of pi, and we are further in multiply by r square, the formula of circle pi r square. So if we are writing a square, we are creating a class of square, and then we are defining its area, and the area will be a square or side square, and for a shape in circle and a square, print shape dot area. So it will be printed as pi r square and side as side square will be a side square. So let's do it in our compiler. By correcting our code, we can get our execution. We are getting our result as pi r square and side square as we are printing shape and area, shape of the circle and area of them. So here we have encapsulation and render method controlling access and built-in behaviors. So encapsulation bundles data and the method that operates on it inside one class, hiding internal details. So encapsulation do is hiding of data and its internal data, which operates on inside on one class. And second point is leading double underscore like self dot and double underscore balance triggers name mangling to discourage direct outside access. And dunder, that means double underscore method let a class define how it behaves with Python's built-in operations. When we talk about dunder str dunder, that controls the print output, and dunder len dunder powers the len, and dunder eq and dunder defines what double equal to means for your object. Here we have dunder methods in action, which making a custom class behave like a built-in type. So how it works is like if we print b, it will automatically calls str and will produce a clean human readable representation of the object. And then b will automatically call len, and the object now behaves like a built-in sequence type. And without these dunder methods, print b would show an unhelpful default like main, book, or object. So let's do it. Now we have done this topic of dunders here. Then we will also remove this. Here we can see that we have initialized our class with our book, our class book, and then we have defined it. In that we have defined title and page numbers, pages, and then we have defined a string of these, and then we have returned title and pages, and the length of pages we also discussed. So in the B, we have taken our book, class book, and we have assigned the uh, title as Python and pages as 101 and total pages as 250. So Python 101 have 250 pages, and we have printed length of B, that is 250. So that has been printed here. So we have some practice problems. What is the purpose of underscore underscore init and underscore underscore method in class? So it is used, it runs automatically whenever a new object is created and is used to set up its initialized attribute. So it is a constructor here. And what is the method of overriding and which OOP concept does it belong to? So method overriding is happen when a child class redefines a method and it inherits from its parent and it belongs to inheritance and enable polymorphism. So what does self-refer to inside a class method means? So self-refer to a specific object instance a method was called on giving access to that instance on attribute. So we have a building class and we have a code to create a class rectangle with width and height attribute and a method area that returns width into height, and we will create an instance with width 5 and height 3, and we will print its area. So here is our code solution, and let's discuss how it will happen. So init will store width and height on the instance at the moment rectangle 5 and 3 is being called, and after that area which will multiply by self dot width and by self dot height using the values stored on a specific object that is 5 and 3, and then we will print r dot area that will call the method, and it will print the integer that will return the value of area of the rectangle having the width as 5 and height as 3. And then the output will be as 15 because 5 into 3 is 15. That will be the output of area of rectangle. This have to be removed. I have no idea how it is happening. So the output has been arrived and the result has been seen. After processing the data, we have created a class rectangle and defined width and height, and we have taken width and height, and we have defined area and the formula of area as self dot width into self dot height, and then we have taken a rectangle with L and B as 3 and 5, and we have printed the area which has been executed in the return statement as L into B, that will be 15 has been seen. Here we have recap of Unit 5, and we have discussed classes. Classes are blueprints. That means objects are instance built with a init function using self to access their own data. And we have understand polymorphism, which means that is something which allow different classes to share a method name while implementing it differently. Another second, we have understand about inheritance, which lets a child class reuse and override behaviors defined in a parent class. And then we have understand about encapsulation and render method like double underscore str or double underscore and length with double underscores with its left and right, and eq with double underscore or under. We can say which control the access and built-in behavior. Now we have file handling and exception handling. So working with files safely and handling errors. We have a reading and writing files. So opening, using and safely closing files will be covered here. So open file name and mode. Then we will return a file with objects, and common modes are like R that will read it, and W that will write it, and A will be used to append. So append is used to add. For example, for surety, so always prefer with open as F if it closes the file automatically even if an error occurs inside, and dot read when returns the whole file as one string, and read line returns one line that will read line returns in a list of lines. And then we will have writing with W mode that will erase any existing content first, and then it will use a mode to add the end without erasing it. So we have a code for writing to a file, creating and then reading back a text file. So how it works is like the first bit The first beta block opens a node.txt in the write mode, and then it will create the file if it does not already exist. And then each f.write call insert text at the file current current position, which will include the manual by slash and having new line, and the file will be closed automatically at the end of each block before the next block begins. So here we have some file modes. Using the write mode for the job, like R is used to read its default value, the file must already exist, and W is used to write, which will create a new file or overwrite an existing one, and A is used to append adds to the end of an existing file, and R plus is used to read and write without truncating the file. Without truncating the file means without having any change in the file. And RB or slash WB used for binary read or write for the next for non-next files. So we have a noting point that forgetting to close a file can lock it from other programs. Like Bit has always handled this correctly. So let's do our code it and execute this code. Here we have here we can see we have opened a file notes.txt as W as F, and we write f.write learning Python in that file in the notes.txt, and we are writing learning Python, and then we are ending that line, and then we are again writing f.write file handling is useful, and with open these notes we are R as F, and then we are content here f.read, and after doing these all, after we are executing by using print statement as print content. Here we are able to see that what we had added in this notes as learning Python, and after that we have added file handling is useful has been printed in the output. So this is how we can do our file handlings. So let's do another example. So here we have reading a file line by line. So let's do this example as well. We have to take back a file. By this way, we can have line 1 having learning Python, and line again we have file handling is useful. So how it is working, we can understand it from here. So the first big block opens notes.txt and in write mode, and will create a function, create the file, if it does not already exist. This is previous one. So here in how it will work is iterating it directly over a file object and yields one line at the time, and it is memory efficient even for huge files. And we use dot strip that will remove the trailing new line character, so the printed output does not show a blank extra line. So this loop pattern is standard and idiomatic way to process a text files in Python. Will be try to accept finally. Here in the third example, we have try, accept, and finally that is used for catching errors without crashing the program. So how does it work? Let's understand. First of all, Python checks except blocks in order and runs the first one whose exceptions type matches. Then finally, always runs whether or not an exception occurred, ideal for cleanup code, and then catching specific exceptions, exception type, and then we have zero division error. Value error is better for practice than bare except. So let's copy this code and let's execute it. We take a user input as 34, then execution is failed. The constant divided by number is being, let's run it again. Let's take our number as 2. Then execution is finished. So here we have a try exception handling. For that we have taken a number as user input, and then we have exception of zero division error. Print you can't divide by zero if we are taking zero. And we have another exception of value error. Print that was not a valid number if that was number bigger than 10. And then finally we will print execution is now finished. So we will write like this. Execution is finished and our result has been gone. So we have done our examples. So we have a raising and creating exceptions. That way triggering and defining your own errors. So the range of keywords lets your own code trigger an exception deliberately. Example raising value error that add message, or built-in exception types include value error, type error, key error, or index error, and file not found. And custom exceptions are like created by defining a new class that inherits from exceptions or a subclasses of it. And custom exceptions are like make error handling more precisely and documenting in a large programs. We have an example for raising a custom exception, and that will be going to our last topic as well. So how does it work is like it is insufficient fund error exceptions like defines a brand new type exception type with inheriting from the base class, and then it will raise an efficient insufficient fund errors to stop them and withdraw the immediately and carries that message upward, and that will accept insufficient fund error as E, that will catch us at especially and exposes the message through E. So let's do this. Let's execute this code. Method at line 11 we are with. So not enough funds have been raised. So this is what we have to get in that code as well. So our code is being well executed. So we have some practice question at the last. So what is the purpose of finally block in exception handling? So it always runs whether or not an exception was raised or not, and commonly used for cleanup like closing a file or a connections, and which file mode adds a new content to the file without erasing what are already there. So A, that is append mode, it adds the new content to the end of the file, leaving existing content untouched. And how do you create a custom exception in Python? So we can create it by defining a class that inherits from exceptions, example class myErrors for exceptions, and then pass, then raising it with the raise myError in the message. So we have done with our Python tutorial. Thanks for watching our video. This was all about Python tutorials. We have completed it from 0 to 16, and this video is in from here. Thank you.